graphically, we can find the distance between two objects using a pretty simple formula. So if we have a graph and we have 2 points, and we don't know where the points are, we do know that they have an x and a y coordinate, right? Because the x coordinate is the horizontal, and the y coordinate is the vertical. Now, can anyone see something that we could do to make this whole system easier if we're the ones drawing these axes and like we're the ones determining what's going on here? What do you think? Do what? Yeah, I agree. Making a triangle would be nice. So go ahead and make that a triangle. And we're just sketching, so it doesn't have to be perfect. But if you want to grab a ruler, you can. All right, so making it a triangle would start to make things easier. There's another, if I was the one to draw these axes and put them here, I think this was silly because I could have made my life easier. Guys, we did not start the year in a normal manner whatsoever. But one of the things I always say is the reason I teach math and I don't go do something else that would make me more money, because trust me, I could go make more money doing something else. I could be an accountant and make quadruple what I make right now probably, because I have friends that do it. But the reason I am a teacher is because I want to help make your life easier. And it doesn't seem like that because I assign you homework every single week. But, that's the whole point behind math, is to make things easier. Both, with how much thinking and how much effort and, just all ways around. So when we think about making these models and making these theorems, and guys, I'm trying to set you up for, as we go deeper into mathematics, there are often multiple ways to think. I want you thinking what's the most efficient way to do this. Guys, if I was drawing this graph, why wouldn't I just put the x and y axes through this point? Wouldn't it be easier if I made this point 0, 0? And then I could just say, well, whatever the x and y is here, if I made this point 0, 0, then whatever this x is the length of the bottom. And whatever this y is the length of this leg. So, but we can't always do that, right? That would be the easiest thing to do. But since we can't always do that, we can pretty quickly create a formula or a mathematical operation. How do we figure out the length of something? Really anything? Gosh, you guys already know the math. I like that you're just getting technical when I'm just trying to talk, right? So what were you going to say, Dwan? How do you find the length of something? Yeah, you're getting technical also. I agree with you guys. You're just already leapfrogging over what I was going to talk about. Distance is difference. That's distance, and I will admit I was older than you when I finally realized, oh, whoa, distance just means difference. What's the difference between here and there? That's the distance, the difference between here and there. So, to find distance, we're going to measure, when we can't measure, we're going to subtract. So, x2 minus x1 would actually give you your horizontal distance because it's your ending point minus your starting point. And then again, we do ending point minus starting point. And yes, order matters. Because as we start to look at positives and negatives, trust me, order matters. So, we talked last week about when we drop a vertical, I think. When we drop a vertical, we know it's perpendicular to the horizontal, right? Horizontal and vertical are inherently perpendicular of each other. So we know that's a right angle. So what we actually know is this is like the hypotenuse. So this is really like a C, right? Sorry, I shouldn't really put that in quotes, but right, our distance, our diagonal, is like a hypotenuse. So guys, really, if I call this A and I call this B, what we're going to do is set up A squared plus B squared equals C squared. Now, I'm actually going to flip this around. So I'm going to bring my A squared plus B squared over to this side so that I can write with the C on the left, quote unquote. So yeah, you should be writing this down. And we said last week to unsquare something, radical. So C, our distance, is actually square root A squared plus B squared. But A squared and B squared we don't actually know what A is and what B is. What did we say A actually is? It's x2 minus x1. Or y2 minus y1. It doesn't matter which one we plug in for A. It's one of them. And B is the other one. Yep. So I don't care if you start with x's or start with y's, and neither does anybody. No math teacher should really ever care if you do the x's first or the y's first, because then we add, and we know with addition, order doesn't matter. And this, ladies and gentlemen, is our derivation of the distance formula. And that's a fancy word for meaning we derived it, and we solved it. Figured it out. We solved it. Derivation of the distance formula. So, there's 100% an exact answer. Now, this is where, if you can use a calculator in a more efficient way versus having to type the whole thing every time, I'm going to save you a bunch of time and effort if you can use a calculator in an efficient way. So especially if you've already upgraded to the MacDaddy graphing ones, but I can show you how to do this on the other ones as well. There is a way to repeat the previous line. So if I type this whole thing into my calculator, and then I can copy it and paste it. Now you could just do this in Desmos too or whatever. I can just change the numbers. But before we go deep down into the calculator stuff, a lot of times we can just do this manually. It's just as quick to do this manually. And, well guys, if we move down to this section, do I need to label that this point is 4,2 and this point is 8,5? Or could I just doodle a triangle? Just doodle a triangle. If I want to find this distance, I don't care what the coordinates are. I can say this is 3 and this is 4. Oh, hey, it's our best friend. The 3, 4, 5. Come on. There it is, triple. You could not think of the word triple. You are correct.
I kept thinking of third.
So in that case, because we set up the triangle that we were going to use, we then didn't even need to do the distance formula. Right here, go ahead and, guys, you can do dotted lines or solid lines. I don't care. Figure out how long that is. Well, that's a 1. 1, 2, 3, 4, 5, 8. Yeah, I don't think that's a Pythagorean triple. So, square root of 8 squared plus 1 squared, right, will equal square root of 64 plus 65. Is that a nice square root? So what do? Just leave it. Unless it asks us to give a decimal answer, which sometimes it will, so we can like actually order an amount of something. Right? I can't order radical 65 of something. So I would need to just make the decimal answer and then round it. Do this last one on your own. I'm going to give you a head start. Yeah. This is the distance formula. So when I ask you, what's the distance formula, you're going to need to know this. And back here, well, not it's all blurry, but yeah, you're going to need it. So if you chose not to, my question is also, what the heck were you doing when all of us were writing this out? All right. So if you're asking generally, do we always? No, we do not always have to write all that down. But we take notes right now in class so that we can reference back to them. Right? Eventually, you'll just have it memorized. What was that noise? Sorry. Sometimes I don't like myself. All right, so this is 4, and this is 9. So I bet right now you're thinking like, Mr. Hudson, you taught us something that now we're just not using. Like you taught us this big, long formula, and we don't need it yet, right? We just keep doing the Pythagorean. You are correct. But on the back, bum, bum, bum. We're not ready for the back, so don't flip over yet. What's 9 squared? 4 squared? Add them. 97. Now, this caution you really need to carry over to the back of the notes too. I don't know if I put the caution back there too. I did not. So, down here, one more quick set. Find the distance of these diagonal lines. Notice, now we don't even have coordinates. But if it's on a coordinate grid, we don't need the actual coordinates. That is the simplified radical form. Remember, sometimes we can write it in that simplified radical form. So I'm not like making you guys do that yet. The simplified radical form. Logan, let's talk about that answer on that specific problem. So is that for this one, the first one? So we got a leg of 6, and then what's our other leg? 10. So then this is really going to come out to be radical 136. Your count was way off? So then you said they gave you what as your answer, Logan? 2 square root 36, but 36 is a perfect square. Are you sure? 34. Here's how. Right, that quick lesson we did the other, and actually I forget if we did it with your group or not. We did it in extensions. Did we never do it in this class? We got to do this. We got to do this. I just need to cover up my paper. All right, here's why your calculator might spit out 2 radical 34 when you think it's radical 136, and that's because they are the same answers. What do we mean by that? Well, math is all about, like, what can I do based off what is still true? And when we test out if this is still true and doesn't ever become not true, we know we can do it. Radical 136 is not a perfect square root. But inside of it, there is a perfect square root. Because I know that 4 times 34, I don't actually know that, my calculator does, equals 136. And this is still equal to radical 136, right? Splitting up, factoring, does not change anything. So I'll write a little thicker. I know some people are giving me the looks of struggling to see. So then, I'm actually allowed that's still allowed. Because, like, this is still, it's still true. If you type it in your calculator, it's still true. So we're allowed to do it because it's still true. And then, square root of 4 is 2. So your calculator made this as pretty as possible. It made the numbers as small as it could without making it into a decimal. That is what we called simplified radical form. Sometimes you'll be asked for simplified radical form, but probably not this year. And I do not need you working in simplified radical form. I just want you to understand how it got there.
Because I remember Tom gave me a problem where I had one of those as the length. It was annoying.
And actually, all you needed to do was type that in your calculator and square it. So you didn't actually have to understand what that number was, but I always want you to.
I didn't know it.
Yeah, and I always want you to understand it. I don't want you working with a number that you don't understand. That's like if I hand you a tool that you don't know how to work. It's like, what is this bow and arrow?
Don't give me a drill. I know how to work it, it's just don't give me a drill.
So give you a hammer and tell you this is not a drill. I know, but I'm not. That's the funny thing. No. My wife and I are what is known as Dinks. We are double income because we both work. Double income, no kids. So D-I-N-K, we're Dinks. So we have nice mountain, or well, not mountain. We have nice road bikes. We have kayaks. We have hobbies. We don't have children. What are you saying that you're not fun? Because you're. You are correct. I get 85 new kids every year. Logan, you're making the exact argument that I always make. Ivan, help me out. What are these leg lengths? 5 and 7. And then what is the hypotenuse length? It is 5 and 6. So we may need to go back and recalculate that math. What is 5 squared? 6 squared? Put them together. Radical 61. We cannot say it backwards. That's like saying 7 the square root of. We're not Yoda, right? So sorry, but order does matter with how we say these things. Guys, I just started season 2 of Mandalorian. I've been busy. Hey, whoever's just making noise. It's another triple.
I actually got it. It's so not.
All right, so now, because, I try to be a nice guy, here's your distance formula again. You don't have to write it out again because I wrote it out for you. But here is where, and now at this point, we've pretty much written computer programs that do this for us, but we have to, you guys have to understand how to do this stuff so you can write the next level of programs, right, and solve all the issues that we've created. When you're given 2 points, guys, it doesn't matter which of these is point 1 and which of these is point 2. Now, here's the problem with me just being straight up honest with you guys versus another math teacher will say, this is x1, y1, and this is x2, y2. But I want you guys to know the truth. It doesn't matter as long as you keep the order the same. So if I do 4 minus 2, I have to then do 7 minus 2. The issue will come in if I do 4 minus 2 and then do 2 minus 7, right? And I accidentally swap around the order. That'll then be wrong. Yeah, sorry, I burped, so I got stopped in my sentence. But I could do 2 minus 4 and 2 minus 7, and they come out to be negative numbers. But what happens when you square a negative? It's positive. So I'm literally going to write this down both ways here, but I want you to write down the work. Don't just do it in a calculator. I want you to write down the work that goes with this one. You're supposed to be doing it on your own right now. I mean this with love, but if you're actually asking that question, your brain's not turned on. If you're thinking about what are we doing and what are we setting up, we are copying essentially what we're doing from this up here, right? The distance formula. So you should be able to know that what we're setting up is subtractions. Doesn't matter which way we do it. If we change direction, things will get goofed up. But as long as we keep it straight which way we go, it's fine. Now, is there a better way? Of course, there's always a better way. No, not better than... So which way of these is better? Yeah, the way that keeps my numbers positive, that's the better way. But will both of these work? Yeah, sure. This way that I wrote in red technically doesn't make actual sense. Because what this looks like is we have a distance of -2 and a distance of -5. But what we know that means, because we're smart mathematicians, is, we did the subtraction in the wrong order. And because subtraction is really a lie and it's all made up anyways, we know that, that distance is actually 2. It mathematically came out to be -2, but it's actually 2. I mean, I'm not going to say I wish I could just go back and undo some stuff they do at lower grades, but I'm only not going to say that because I'm recording right now. No, but I said I'm not going to say it. No, it's still going. Now, this gets tougher when we have all negative numbers. Wait, does it? Negatives are inherently tougher normally. But well, think about it. If every number is negative, distances are going to solve the exact same as when it were positive. Sophia?
The way I always do it, I always start in the form, but then I will, when it comes, because where it was -2 and -5 on the last problem for you, that's when I would actually put it through absolute value, just because it makes it easier with positive numbers. I know it's the same, it makes my brain work easier.
Yeah, if I technically write out the whole thing, it's that. But minus negatives are actually positives, so that's -9 plus 2. So that's -7. So if I did these in the other order, I would have gotten +7. -6 plus 2. -4. 49, 16. -6 minus -2. Now, with lots of trepidation, I'm going to tell you a shortcut. With lots of trepidation, guys, we could just think. Now, the problem is, my shortcut is telling you to think. So, the shortcut, you have to turn your brain on. But how far is it, is what we're talking about, right? How far is it? Distance. So, if we think about what this is, this formula is actually, and I want you to come up here and write this, it's the square root of delta x squared. Guys, remember that delta means the change in. If we can just evaluate how far did x change and how far did y change, I don't need to do this complicated work. So if I can turn my brain on and say, oh, well, from -2 to -9 is a distance of 7, doesn't matter positive, negative, like it's 7, right? Distance is always positive. So my delta x is 7. And then I think to myself, how far is it from -2 to -6? And again, if they're both negative, I can think about them both like positives, and delta y is 4. So exactly what we get down to, if we just think. That's all I'm telling you to do. Well, that's good. So essentially, what that means is if both corresponding values have the same sign, you can ignore the sign, right? Like, what's the distance between -6 and -8? 2. Now, if what I just said with the shortcut doesn't make sense, ignore everything I said and just go back to doing the math, right? We can always just do the math. Okay. So here, if I think it through in the shortcut method, delta x is 2, delta y from 6 to 4 is also a distance of 2. Even though it would maybe come out negative when I do subtraction in a specific order, remember, it doesn't matter. Negative would just be direction. Did I go left? Did I go right? Well, it doesn't matter. So this will be square root of, and 2 squared is 4, plus 2 squared, square root of 8. Now in the end, you can always just do the math. So since this one has positive, negative, I could do the method we just did, or I could again just do the math. So for the last one here, I'm just going to do the math. first point minus my second point. So then I need to make sure I do my first point minus my second point. Negative 3 plus 7. So then, let's, for fun, push this into simplified radical form. So we can factor this into square root of 16 times 2. Yep. So then it is 4 radical 2. If you wanted to put it into simplified radical form. It depends how it says to when you when you click the box and it says type your answer as. If it says simplified radical form, it'll accept it. Yeah. The other answer I can give you is just try it. Worst case scenario, you just cycle through the activity, and then start it over. If you get frustrated, what I do when I get frustrated on Khan is I just go through the activity and I hit 5 on every question and just get it. And then I just start over. Now, I shouldn't say that because what you should do is click the get a hint for each one and quickly scan the hint. I like your genuine yeah, if you click get a hint, remember it with the videos, you can just click it and walk away. You don't gain anything from that. Guys, the funny thing is, a lot of times adults know what kids are doing, and it's just whether or not we want to, do I care enough to care? Do I care enough to say something oh no, my kid's sneaking out of their bedroom. I can see where they're going. I can see whatever. I don't care. I don't have kids, but you know what I mean? Your parents probably know some of the stuff that you do, and they're just whatever. They get caught, they'll learn from it. So if you're pulling a fast one on Khan, you're just gonna end up getting a progressing on a mastery, and we'll deal with it eventually. Audrey? Yeah. Did you rat her out, or did you? No, I went back to bed. Listen, I went back to bed and immediately forgot. Yeah. I hope she's okay. My parents paid you for every time you did something What? Now wait. What if you guys just made stuff up and work together and split the bounty? What if it's No, him and his sister. Oh, it's no. I know Logan and his sister. They are not that close. Oh, I'm sure. I know you are not that close. All right, so. Alright, I'm about to blow your mind. So, three dimensions, the number 3 has a lot more impact than I ever realized when I was your age. So this is why I try to teach this with not let's memorize formulas, but let's look at how super cool this is. So, this needs washed out anyways, regretfully. It's pretty much empty. And I have been getting my water from the drinking fountain, sadly. So, if we have a cube, its volume can be found by length times width times height, right? But we know with a cube, its length and its width and its height are all the same because the net pieces are all squares, right? Because it's a cube. So we could put some water in it, right? So especially when we were over at Phoenix with carpet and everything. I used to, like, if a kid was, like, you know, mouthing off that day or, like, wouldn't stop talking, I'd, like, have them come sit up front and I'd do this above their head. Now I might get in trouble for that, so I realize that's probably something I shouldn't do. Yeah, see, that's what would end up happening. I'd end up on the front page of the news. Alright, now hold on. I know you're excited, but I only got a couple minutes left. This pyramid perfectly fits on here. Right? Yeah, it's a pretty house. Right? Now, here's what's really weird. You guys don't even know what I'm doing, unless you do. Have you already seen this before?
I don't know.
What's going to happen when I put the pyramid in here? Not very much, right? But it is going to overfill. It is not. So, my pyramid is perfectly displacing a pyramid worth of water inside the cube. Right? This is the best that I can do this. Now, when I let it float up, to anyone who said it's a perfect half, not, right? We can see it's not. It is not. It looks like it might be 3/4. So, then, and guys, before they could, like, measure, and before they had, like, volume, like, I have a little volume container I can measure with. This is the stuff they would do, right? You pour back and forth and you figure stuff out. So now, if I spill water everywhere. So, there's still water to be poured. So, it's exactly 3. So, 1 cube will fill the pyramid exactly 3 times. Now, do you think that's wild?
No.
Same thing happens.
Wait, what?
So, you know McDonald's ice cream cones are not cones?
No, I've never had McDonald's ice cream.
Well, probably good for you, like for real.
Okay, they're not bad.
So, an ice cream cone, you think it's a great, like, oh yeah, it's an ice cream cone. It's a ripoff!
Yeah.
Any ice cream establishment selling their ice cream in a cone, I think, at the end of the day, is trying to rip you off, because if they gave you an ice cream cup, right, like, we have all of this ice cream, but the same size of cone, right, same height, we can do the same thing over again. If I displace my cone worth of water, right, out of my cylinder, it's that same 1/3 relationship. So guys, think about this. This is the craziness. Is when we have 3-dimension shapes, right? The relationship between them is 3. Right? That's our scale factor. Is 1 cylinder is 3 cones, or it takes 3 cones to be 1 cylinder, or 1 cone is 1/3, right? If we say how much 1 cone is compared to the cylinder, 1 cylinder plus, so now we're still missing 1/3, but that's 1/3 because we've got 1/3, filled up.
This reminds me of the coach where we did play with the cups of water. Oh, yeah.
Yeah, in COVID times, we can't really all play with the same water right now. Yeah, hold on. Oh, the last thing we need to talk about.
No more. My brain's already blown. Please, no more. My brain's already blown. My brain is still fried. That's not good.
I forget if this works or not. I think I'm missing one of these. Oh yeah, that's it. Okay. So hold on.
No more.
Cube, triangular prism, right? Our relationship here is the height, quote unquote. But if we turn that and say the base, right? So, what relationship is going to happen here, guys? You should already, yeah, it's a half, right?
You should use the pouring thing right there. Yeah, they have the pouring.
Okay, well, I've obviously spilled a lot of water because I have very little water to work with. But yeah, so if we could do all the fills again, if we filled up the cube and poured out a triangular prism, the cube would still have half of its water left. Because as we know, triangles compared to their counterparts of a rectangle are half of the area, meaning half of the volume. All right, that's all I got for today. Hold up. I'm going to come around with wipes because it's safer that way instead of you guys all clustering up here. I'll still come in first.
Thank you for blowing our mind.
Can I drop the mic?
I love it, like area and volume applications. I know you got like a bigger surface area there.
Yeah, I got big area.
It's not worse than yours.
And then you put this over.
No.
No, you're not allowed to.
See a tie-dye string.
It's illegal.
Alright, there you go. Thank you. I know, it is pretty sweet.
Yeah. It's better than the box.
You're telling me this thing is sick?
Guys, somebody made a mess.
Man, who was this?
Gee, I wonder. It's not like when Mr. Hudson was pouring water. That's
Just don't know what's going on.